All right, Precalc, welcome back. Today we get past SOHCAHTOA and on into degrees and radians. Degrees is something you guys are very familiar with, mostly from all of your experience with triangles. So it's very convenient and nice to describe the size of angles with degree measures. You guys don't really know what a degree is or care what a degree is, but you could explain what a degree is by writing a really small angle. That's a degree. Okay? It's been useful up to now, and now we need to change how we measure angles, because we're going to stop thinking about angles in terms of triangles, and we're going to start thinking about angles in terms of rotation. So the best way I can kind of explain that is for you to think about a wheel. And a wheel has a radius. Okay? And so all of this type of math started getting important when we realized how many things in our universe rotate. Tires rotate, our Earth is rotating, our limbs rotate on our body. Obviously, the moon is rotating around the sun. No, the moon is rotating around the Earth is rotating around the sun. There's just all sorts of things in rotation. So, at that point, angles stop being a good way to describe things, because we can have a bunch of rotation. So what I just drew for you there is pretty well known, and that is a 360-degree rotation. Okay? And a 360-degree rotation would be the same thing as a 720-degree rotation. And so we're going to start calling those coterminal angles in this chapter, but that's not kind of the point of this lesson. Okay? Today we are going to focus on what a radian is. And simply put, a radian is a new way to measure an angle. Okay? So if I drew an angle inside of this circle, okay, to me that looks like it's about 135 degrees or so. Okay? Well, we want to figure out how many radians that is. And so I'm going to teach you how to do that, and then I'm going to come back at the very end and explain to you what a radian actually is. Okay? So, when we have degrees and we want to know how many radians that is, we have a formula. It's very simple. We take the amount of degree, we multiply it by pi, and we divide by 180, and then we simplify. So, for example, in the example I just showed you, how can we turn 135 degrees into radians? So, I would take how many degrees we have, which is 135. I would multiply it by pi. Don't do like you would in like the beginning of your life where you actually multiplied by 3.14. Just leave radians in terms of pi. It's helpful for your audience because the guy that's reading it or the girl that's reading it, as soon as they see pi involved, if they're smart and things aren't screwed up, they're just going to know that you're talking about radians. So, look, I followed the formula. I took my degree measure, I multiplied by pi, I divided by 180. Now we can simplify that. So can someone in their calculator do 135 divided by 5 for me, please? Thanks, Jimmy. Is it 6? Uh-oh. 135 divided by 5, it should be 27. And 180 divided by 5 is 36. So we can keep going. We can keep simplifying that fraction by dividing each of them by 9. So you get 3 pi over 4. So here's what we just learned. Okay? 135 degrees as an angle measure is the exact same thing as 3 pi over 4 radians, or 3/4 pi, okay? Now we also have a formula on how to go from radians to degrees. So let's say we had 4 pi radians. How many degrees is that? Well, here's the formula. You take how many radians you have, you multiply it by 180, and you divide it by pi. Okay? So I would do 4 pi times 180 divided by pi. The pi's cancel, which is what you want. You want to write your answer in just good old-fashioned numbers when it comes to degrees. So 4 pi radians is equal to 720 degrees. Okay? Now, if at any point you ever forget either of these formulas, all you have to do is remember an important proportion. Okay? 360 degrees is equal to 2 pi radians. Or if you prefer, you could say 180 degrees is equal to pi radians. Okay? Now, let's examine something. This right here, if you can remember something, is the key to understanding what a radian actually is. Do you recognize 2 pi r? Does anyone remember what that is? Very good. That's the circumference formula. And that is exactly where radians come from. Pi d, or 2 pi r, is equal to the circumference. Now, what's the circumference of a circle represent? That's right, the length around a circle. So think about it. Now, instead of talking about the length around a circle, we're talking about 2 pi r radians in angles represents an entire circle, 360 degrees. Okay? Pi r, pi radians, represents half of a circle. That's where this comes from. It's nothing that anyone invented. Okay? They just kind of utilized it because it was convenient for them. So let's go one more thing, and then I'll go back to the beginning slide and explain what the heck a radian actually is. Okay? So arc length, this is kind of a confusing but cool formula, is radians times radius. So what does arc length mean? If I ordered a piece of pizza, okay, and I knew that the radius of a large pizza is 10 inches, if I wanted to know the length of the crust of half of the pizza, if I took a tape measure and measured this crust of half the pizza, how long is it? So if I had like a cockroach on my pizza and he was walking around the pizza, how far would the cockroach walk if it walked from one side of the pizza to the other side of the pizza? We can simply find that by doing radius times radian. Now, our radius is 10. We just learned that half of a circle is 180 degrees, which is pi radians. Okay? So, arc length would be 10 pi in this. And that'd be 10 pi inches. And if that doesn't make sense, that's fine. You could write it as a decimal, and it'd be 31.4 inches. And that's how far the cockroach would have to walk to get halfway around your pizza. Okay? It's not a completely new thing. So, now let me go back to the first slide and explain to you guys what a radian is. This is amazing. I actually taught for like 5 years and I didn't know this. Okay? This right here, this blue line, represents R. If we were able to take this blue line and curve it, that would also be R. So a radian is the length of one radius but curved along the circle. It's an arc length whose measure is the same thing as the radius of the circle. Okay? And so if that was 1 radian, this would be 2. This would be 3. And so we'd fall short by using 3 radians of getting halfway around the circle. And the amazing thing is, if you want to know what is left, this is 0.1419. It's 3.1419 radians. Do you recognize that number? To go halfway around a circle. That's where pi came from. Obviously, pi is the ratio between the circumference and the diameter. But what's crazy is if this radius was made of rubber and you could curve it, it would take 1 radius, 2 radii, 3 radii, plus a little bit more to get back to the other side of the axis. And that's what a radian is. It is the length of the radius mapped out along the circle. So we will be working in radians for the next month. We will be going back and forth between radians and degrees, and you have to be great at that. So if you struggle a little bit, come back and check out this video a couple times. Peace. Miss you.